Hello, my name is Angad Daryani. I'm an IBDP student at Jamnabai Nursi International School, and in the past 4 years, I've been working with low-cost computing as well as open source microcontroller platforms to develop various projects for the healthcare industry. For my computer science eye, my client, Kunar Peripherals, wanted me to build a low-cost air quality monitoring device which could display all of the data from our surrounding air on a low-cost LCD, a 16 by 2 character LCD, as well as data log all of this data in real time on a micro SD card. For this project, I used the Arduino open source microcontroller platform with its programming IDE. Since a lot of the data for this platform is easily available and there are a lot of tutorials online, I chose to use Arduino for my project instead of any other microcontroller or low-cost computing platform like the Raspberry Pi or the $9 chip computer. Now I'll explain what each of the pins on the Arduino does before we move on to the final project that I built. For my project, as mentioned earlier, I used the Arduino platform, which comes with a hardware board as well as a software programming environment. The Arduino board has two types of pins, digital and analog, and both of these pins are I/O pins. That is, you can use them for input or output. The analog pins can take in values between 0 and 1023, since 1024 will become digital, that is the 10-bit resolution, and the digital pins can read a high or a low, that's a 1 or a 0. Since this is the most common used board, Arduino Uno, and it had limited pins and I needed more pins for my project, I chose to go with the Arduino Mega platform, which is the same kind of board and the same programming environment but with more pins and more memory on the chip. Since we were using the Arduino Mega, which is a big enough board anyways, it is the size of a smartphone, I chose to use a prototyping board and put in all the components on the same board such that it can be mounted on the Arduino Mega once put together. Now we can see on this board that we have a micro SD card breakout board, that is, you can put in an SD card and it sends all the data to your microcontroller platform. We have a real-time clock, this is known as the tiny RTC, and it communicates with the Arduino using the I2C bus, and I've mentioned details about I2C in my criterion B. We have a potentiometer, that is a variable resistor, in order to control the brightness of the 16 by 2 character LCD. That is, it can display 32 characters in total, 16 per row. In order to receive the data, I have a sharp dust particle counting sensor. The dust particles go through this and the LED light inside diffracts and refracts when it interacts with dust particles, and that is the data which is given to our Arduino board via the serial. And we have a carbon monoxide MQ7 sensor, which is an inbuilt heater, and the change in this temperature affects the plate inside, which reacts to the carbon monoxide in the air, and we get all of that data through the analog pin on the Arduino. You can also see a small push button here, as the client requested. When the push button is pressed, the Arduino should start recording all the data on the SD card, and when it is pressed again, it should stop recording. And while all these recordings are taking place, it should fetch the time from the real-time clock and store it in a separate array next to all of the other data. And when it is pressed for the second time, the device should display the maximum value for carbon monoxide with the time and the maximum value for dust particles with the time. And we achieve this in the following way. Okay, so first I've connected a push button to the Arduino board, and I'm going to run a simple program to count the number of times the button was pressed. So I'm just going to go ahead and upload this code. It's uploading. It's done uploading. Now we can go to the serial monitor, and we can just see. Now I press this button once, it shows number of times the button pushed was 1, and then it switches off. Again, I press it again, it shows it as twice. Now keep pressing 3, 4, 5, 6, 7, 8, 9, 10. So we can see that it's successfully counting the number of times the button was pressed. Okay, we have the Arduino connected to the RTC module now, and we're going to upload the code to see if the RTC can print the time on our serial monitor. So we can see that it's printing 1935 020304, and the time is actually on the computer 1935. Okay, so now I'm going to try to read data of the SD card directly through the serial monitor. So I've put in a new file called test.txt, and I've loaded a word called Angad's comp I in it. This is the file name which we're opening, and it shows this is Angad's comp I. So now I'm going to upload the code which writes the test file to the SD card, and we can see if that works. It shows card inserted, so one check done. It's initializing the SD card first, that's also done, and then the last it's writing a file called text.txt, and that's done too. Okay, so now I've connected the LCD as well as the dust sensor to the Arduino, and I've written a small program so that the dust sensor values are displayed on the LCD instead of just a hello world. Okay, so now it's done uploading, and we should be able to see the LCD display the value of the dust sensors. So we can see that it's changing every second. It's constant right now. But if I were to insert something in the dust sensor, probably will, yeah, it changes. Yeah. So if I put a wire inside the dust sensor, it increases and decreases. Yeah, so we can see how two modules are combined to do one task, and this is how I carried out the rest of my project. So I connected the carbon monoxide sensor, the SD card module, and the push button to the same Arduino board, and did multiple tasks with it.